Hello, everyone. Good afternoon to everyone on this call, and welcome to the second session of our Azure Datafest event in Singapore. Last week, as some of you may remember, we had spoken about the possible ways to ingest data into Azure and how to go about implementing an architecture for a large data estate, addressing your analytics requirements. So today, we will be introducing you to yet another powerful technology, Azure Data Explorer, which is a fast, fully managed data analytics service for real-time analysis on large volumes of data streaming into Azure. The objective of today's session is to bring you up to speed with Azure Data Explorer, explaining what the service's capabilities are and how you can get started ingesting and querying your datasets. And then next week, if we look at the calendar, we will build upon the content of today, delving deeper into the topic of building high concurrent applications over Azure Data Explorer, right? And as usual, before we get started, a few notes. Switching slides, just give me a second. Yeah, so this is the calendar I was talking about. Right, today is 14 October, an introduction to Data Explorer, and then next week is about building high concurrent applications on it. And a few notes for us. We can change slide. All right, so at Microsoft, as you know, we see sustainability and humanity's response to climate change as one of the greatest challenges of our lifetime. And we believe it is not too late to plan for a cleaner and greener future. And so again, as part of our commitment to sustainability, I would like to state that Microsoft Singapore will be planting a tree for every person attending this event today. Now, a few housekeeping rules. The session is being recorded and will be available on demand afterwards. So in case you want to watch it again, the link will be made available to you. You will have, you can see a live event Q&A. So although everybody is muted, you can ask questions in the Q&A. And there will be a few moderators, including myself, on the line to answer those Q&A. You should be able to see a panel over there that you can open. But at the end, so feel free to make it, interactive questions as we go along the presentations. Just at the end, there will also be about 10 minutes of Q&A where we can elaborate on some of the key questions. Right, next slide. So let me introduce you to Svea and Minnie, who are program managers for Azure Data Explorer and are the key team members that are shaping and evolving the product. So Svea will be presenting today, and myself, Andrea, and Minnie will be on the line answering your questions. So this, Svea, over to you.
Hey everyone. Thank you so much for taking the time to learn about Azure Data Explorer. Actually, this is a very exciting moment. I think it's the first time that we have a session in Singapore. And actually, it was very exciting also to hear the news that Microsoft is going to give a tree for each and every person. Okay, so my name is Svea Gitlin. I'm a PM manager at Cousteau, Azure Data Explorer, leading the user experience, data management, and field readiness. And today with me, Minnie. Minnie, would you like to introduce yourself?
Sorry, I was just toggling between mute, unmute. Hi, everyone. Thanks for joining. My name is Minnie Walia. I'm a program manager on Azure Data Explorer product group, same team as Svea. Looking forward to your questions on the chat. Enjoy the session.
Thank you, Minnie. So Minnie and Andrea are here to answer your questions. So please don't hesitate to post it in the Q&A area. And let's start. Okay, what do we have in our agenda for today? First of all, we will start with a short overview what Azure Data Explorer is. We will continue with a demo, actually end-to-end demo. We'll start with how to select your cluster, to create a cluster database, bring your first data, couple of queries, and we will see with the time if we can go also to dashboards. And then we will talk about what should be next. Some customer case studies. It's also nice to see the opportunities over there. And we will finish with a Q&A. Ready or not, here we start. Telemetry data is everywhere. We find it in our IoT sensors, logs, click streams. It drives advance in the connected devices. We find it in our homes, buildings, factories, everywhere actually. And those telemetry data is the fueling of the digital transformation. It's generating terabytes and petabytes of data every day. And in the world of big data, we can divide processing into 3 temperatures, just for us to help us to understand what type of services we can handle in this area. So the first, we have the hot, the warm, and the cold. In the first area, the hot, there are systems with high sensitivity for data freshness, usually milliseconds up to 1 second max, run predefined queries with direct response and retention of a couple of hours, sometimes a couple of days, no more. Those systems, the hot system, usually been used for monitoring and alerting. Whenever you need an immediate response to streaming data, usually you will pick one of our hot services solution for those areas. For Microsoft, for example, we have the Azure Stream Analytics solution. On the other side, we have the warm area. Again, actually, very different. We have the cold system, sorry. A very different behavior. Usually have a long processing scenarios, ingestion every couple of days. Usually also the ingestion takes a couple of hours, sometimes a couple of days even. All the processing, again, scanning, in many cases, the entire data set for hours, sometimes days and even weeks. The retention is very long, months, years, even many years. And the actual fresh data has a very minimum impact on the overall results whenever we run queries. Those systems are usually being used to train models, to run reports that required to scan the entire data set. And in the wide area between the hot and the cold, we have the warm system. System with unpredicted requirements for query that ingest endless amount of raw data that been stored with freshness of couple of hours up to a couple of days, months, even years of information. Need to store up to a couple of terabytes, even petabytes of data, even petabytes of information. And the very clear definition about the warm area, that we need high freshness, run queries with very high performance, unpredicted requirements for query. Nothing is predefined. Everything is like exploration experience. You have data, you have issue, you start to explore. You would like to get a new insight on your data, you start to explore. And the data set need to provide you the highest performance and the freshness data together with the existing data to answer your question and queries in the precise way. In the warm area, we have Azure Data Explorer, a dataset platform for big data exploration with full analytics capabilities and high performance. Let's try to understand better what is Azure Data Explorer. So Azure Data Explorer is a big data analytics cloud platform optimized for interactive head-hoc query. To understand this sentence as a whole, it's very complicated. So let's start to break it into pieces. First of all, big data. Big data stand for the 3V, volume, velocity, and variety. Volume of data from a couple of gigabytes up to terabytes and even petabytes of information. Velocity, the volume of the data that is ingested all the time in the system. It's not one time, it's not once in a while. It's stream data that stream into the service with high volume. And variety of sources, variety of formats, variety of data structure, variety of cloud services, on-prem, cloud. Everything is needed in the world of big data. Azure Data Explorer is also support, and one more definition for big data is the need that is the data is mainly append. Most of the data is added, no many transaction of updates and delete. Full analytics capabilities for simple features like for filters, scanning, join, union, to very complicated time series analytics capabilities that enable you to run anomaly detection, to scan over your data, also to run your own Python code as a function and get results over the information. Azure Data Explorer was built to enable all the analytical capabilities that exist today in actually even advanced more capabilities that exist in every database for small data and regular data amount, but to run it over volume of information, terabytes and petabytes of information, and get the highest performance and with the highest freshness of the information. Azure Data Explorer is a cloud service currently run only on Azure, and it's also fully managed, meaning that from the bottom tier, all the resources is managed by Azure, like any other service. Higher level, it also has the auto-scale management up and down, and this is important. Whenever you have unnecessary resources that you say that you don't really need those resources, the service will recognize it and reduce the amount of SKUs to optimize the cost efficiency. And also it's a fully managed database, meaning that all the parallelism, indexing, partitions, concurrency queries and concurrent user, everything is managed by the service, and you can focus on the actual logic of the business instead of maintaining the infrastructure of the service. Okay. Can you see me and see my slides?
Yes, we are.
Yes, we are. Wonderful. Okay. Azure Data Explorer is a platform like any other database. Whenever you need a database that can provide the high freshness and also the high performance capability, and you have also a need for high volume of data, you can consider Azure Data Explorer as your preferred database service. ADX, Azure Data Explorer, was built with one agenda to enable those scenarios for big data. So everything was predefined, and all new and each new feature is designed to support those capabilities and to verify that we will provide and continue to provide the best performance and the best freshness to our customers. ADX, Azure Data Explorer, works with KQL, Cousteau Query Language, with its very intuitive query language, very natural language kind of query statements, and that we will demonstrate later. So in a few words, Azure Data Explorer is interactive analytics service for fast-flowing data. It's platform that supports near real-time, less than 10 seconds from ingestion to query, with insight and running queries in couple of even for milliseconds and a little bit and up on gigabytes, terabytes, and even petabyte scale. It's fully managed, as I mentioned, that enable you to build your own SaaS application on multi-tenant scenarios or single-tenant SaaS analytics solution for time series, logs, events, transactions, and security solution on your security data. All the certification and all the requirements to support security is already enabled in the system. No infrastructure need and no management is required to work with Azure Data Explorer. It's also with KQL, Cousteau Query Language, Azure Data Explorer democratize the self-service to everyone. Each and every person in the organization has the ability to search information and to query and get insight from the unlimited amount of data. And this is a proven technology inside Microsoft since back then in 2015, 4 people from Power BI had the requirements to work with endless amount of logs internally. They searched for a solution. At that time, they used to work with external solution that work best for them. But at some point, it didn't provide the results, and also the cost was really high. So they decided to find their own solution and to build it. You know, very talented people inside Microsoft, they apply a request and they got funding to develop their own solution in 6 months. And if it will work, they will get a further funding for continuing. But if it won't, they will close the project and that's it. And as you can figure it out, after only a couple of months, they already had the first customers, internal customers, and very soon, like a viral service, it's run inside Microsoft from one service from one project to another. And pretty soon, most of Microsoft services decided to use Azure Data Explorer as their own telemetry system. Another step was happening in 2017. When few Microsoft solutions like Defender, like Log Analytics, like IoT Hub and others, they decided to build their entire solution on top of Azure Data Explorer. And even more, they decided to expose the KQL, Cousteau Query Language, the user experience, the query language of Cousteau to their own customers, and to make it like a first-tier service inside Microsoft. At this point, we had the opportunity to train our service to support customers, external customers, in very high volume to respond to Microsoft and Azure requirements for real customer outside, and also the 3 and the 5/9 of availability. And it was only natural and only, you know, a growing moment that soon after, people that used to work with Azure Data Explorer inside Microsoft went out to key roles in other companies, and they ask for Cousteau, for Azure Data Explorer. Cousteau is the code name for Azure Data Explorer, sorry for that. So they ask for Azure Data Explorer to be part of their organization also as an external company. So by February 2019, Azure Data Explorer went GA to public customers and with general availability. So Azure Data Explorer has a key role in the Microsoft digital transformation. With high, massive scale, think about numbers. We have more than 25, and those are not the updated numbers. I have to be honest with you. I didn't have the opportunity to check the latest, but we have more than 25 petabytes data ingested every day, came up to more than 2 exabytes overall in our services, and with 20 more billions of queries every month. Every second, we have dozens of thousands of queries run around the clock, around the world. So this is a proven technology with a variety of solutions. What are the key usage patterns for Azure Data Explorer? There are many, and each and every customer decides to do it differently. But I would like to mention the main two. First of all, use ADX as a telemetry data to collect events, IoT events, logs from different sources, different sensors into the service to enable you to run analytics and analysis of your data in near real time over the entire solution. And the second common scenario is actually build your database solution, your entire service solution on top of Cousteau as a database platform, and to enable your customer high freshness to your data, the ability to run queries and sorting inside their data in smooth user experience. We have customers from all over the verticals, retail, finance, and others that leveraging Cousteau Azure Data Explorer in many ways and has a very certified experience. You can read more in a Microsoft customer stories site. Just search for Azure Data Explorer and see some of the cases and the architectures that our customer leverage the service. Okay, so I think that I talked enough. I made a lot of noise till now. So now let's move. Would you like to see that? Do you want to start to see how do you start with your own journey with Azure Data Explorer? Well, yes or no? Let's start. Okay. So first of all, welcome to Azure Portal. This is most likely most of you are already familiar. This is the Azure Portal. Here you can look for Azure Data. And at this point, you will get a list of your cluster, and most likely for those that it's the first one, you will get an empty list. For me, I have a couple. So I will create a new one. Let's see what is our. It will take a couple of seconds, but it's not because most likely the Wi-Fi, but we will be patient with it. Okay, at this point, we need to select the subscription. Of course, a resource group. I don't have my own resource group. Really? Ah, I do. We need to put a name. Region. Region is also important to your decision because you would like the service to be as close to your customer other than your development center, if just to optimize the network requirements and the network performance. At this point, you need to select the cluster size. This is a very important phase. At this point, my suggestion to you, go to the Azure Data Explorer site, to the calculator, and put the details. For example, let's do it. ADX.cost. You will have a calculator that is very similar, identical to the one that actually it's this one. At this point, you need to put some of the parameters of your service. Let's get into Azure Data Explorer. And now you just need to put the parameters, how many data you collect every day, what is the requirements for hot cache, and what is the requirements for total retention. Hot cache is the data that you need to query often, and the total retention is data that you need to store from legal aspect, for rarely queries, and etc., etc. So it's something that, and also impact the resources that will be allocated. And of course, in Azure Data Explorer, you will see in a second, he has a very good compressed mechanism and technology. So even though that you will have dozens of terabytes of information, only the compressed size will be required to be stored. And in many cases, the ratio is 1:7, 1:8. So it's optimized also the resources and of course the cost of the data required. At this point, you could put the numbers and then you would get a recommendation of the required, also the cost and also the required service. Okay, now after we discover that, I can go and select my load. For this one, I will take a dev. Compute, I can select which one I need. If I need something bigger, I can also go whether I want a storage optimization or a compute optimization, more data, less compute, more compute, less data, or both of them. Okay, next is, as I described, whether you would like to manage the scale manually or whether you would like to provide, give the service the freedom to control it, but with your guidelines of the minimum and the maximum amount of instances. ADX can support streaming and queuing. To enable streaming, you need to select it. Also, purge for GDPR is supported, and of course, auto scale just to optimize cost. If you see that the service is not in use for a long period, verify. Give the freedom to the service to auto suspend itself just for cost optimization. And
yes. Sorry to jump in.
Definitely.
Can you make maybe the browser a little bit bigger, zoom in, because some audience have some difficulties in reading. Yeah, perfect, I think.
Okay, thanks. Thank you for mentioning that. Security aspect, of course, all the requirements for security, whether it's encryption, customers' keys, VNet, private VNet, everything is supported by the service, and you can define it as part of the cluster definition or later. Diagnostic setting, collecting additional logs on the service just to give you more information about your cluster's status, and later ingestion, queries, performance on optimization, tagging, Azure stuff, review, and create. Okay, I didn't fill the details, just so at this point, once you review it, you click on the create button. It will take a couple of minutes. It's let's say, it depends on the size of the cluster, between 5 to 10 minutes. It's required to allocate the resources from Azure and to start to build the service. And then you will have a working environment. I prepare in advance just to save us the time waiting for the service to be allocated. A new cluster, empty cluster, has nothing on top on it. Okay, let's me. And once the cluster is ready, you will see this page. This is the main welcome experience that you have. First of all, welcome. You have a service creation, cluster creation. Good luck, good job with that. Next, you need to create your first database. How do you do so? You click on the create button and get the following screen. You need to define a name and retention. As I mentioned, you have two types of retention: the long time retention, including history. How long do you want to keep your data? You know, from legal aspects, from training experiences, from any reason, you can collect your data for further period than the actual daily needs. And the cache periods is the data that you will interact on a daily basis and is required the best performance. Great. Okay, database creation is in progress. Let's wait a second, and I have a new database. Good job, Svea. Next, now I have a cluster, I have a database, an empty one, and I would like to ingest new data. And click on the ingest new data button, which it's kind of self-explanatory, and I get this page. At this area, I have the ability to ingest new data. First of all, this is my cluster, this is my database, and I need to create a new table because I don't have existing one. And if I see here, it's empty list. So I'm not very creative with names. I will keep doing with my own, with the names that I already have. And this is so I define the destination, the table that the data will ingest into, and I'm moving next to the source. I can bring data from a variety of sources, from blobs, from containers, from ADLS Gen 2, from Event Hub, from Event Grid, and of course from local files. I need to select my source, and for my first demo, I will select file. And once I select my source, I just need to put the parameters to attach this specific source. For my first demo, I will start with file. And now I'm selected a couple of JSON files with information. At the backend, the service uploads these files and also takes samples of those data set and running an inference to infer the schema structure to adjust and to support those files. Okay, the selected file, the selected source with the star is the one that will define the schema structure for this table. Uploading for the first cluster for the first time sometimes takes a couple of seconds, but here you can see that everything was uploaded. I have a star that this file is the one that will define the schema structure. And I move into the next step. As I mentioned before, an inference run in the at the backend and select the sampling of the data and infer the schema. And this is the suggested schema to support this data source. You can see here the commands that is needed to create this table, the mapping, and also to ingest the data. So it's also a learning experience for you. But here you can see the table structure. At this point, you can delete column, change data sets, update column structure, add transformation on your data set transformation, whether you have a number that you would like to transfer to be a date in a different format. And also you can change the nested level of ADX support three types of data: structure, semi-structure, and free text, unstructured at all. Structure, you know, the regular numbers, dates, etc., etc. Semi-structure, any nested format like JSON, like XML, like arrays of arrays, whatever you think. Dynamic columns is very good for data that is adjusting often, and you would like to control the data structure and to enable queries of ingesting of bulk of data, and later to enable you to query different type of formats and different type of structure. But easily, you can also decide to extract all the information into separate columns instead of having dynamics columns like I did here. And by clicking on the summary page, I actually starting to ingest the data. First, I'm creating the table, the mapping, and I'm queuing all the ingestion sources to be ingested. And then I'm starting an ingestion flow that is running now in real time, and you can see that is already completed. All the data was ingested, seven files that I was were selected. This is a preview of the information that you can see here. And even more important, that you have here a set of tools. First of all, you can do undo, reverse everything. You decided that you did something wrong, you just wanted to test something and you want to revert everything, no problem. Click on the undo. You just want to delete the new data if it's alter of existing table, or you just want to see the schema of the new tables that you have just, congratulations, have created. And the very next step is to query the information. So you click on the take 10, a new tab will be opened with a very simple query statement of take 10, which is take sample of 10 records of the new table, and here it is. Okay, so what we saw till now, we have created a cluster, we have created database, we ingest new data. There are a bunch of options to ingest your data. I just presented a file upload, but you can have the same one with container, that you can select one of your containers that exist in the system. Instead of even browsing anything, everything is available for you here. You just need to select the cluster, the container, and the data will be ingested. And you also can define event grid, which is a blob agent that ingests data automatically, continuously, whenever a new blob is created on this container. Also, from Event Hub, you just need to attach the Events Hub, and the service will listen to events, take a sample of the streaming events, and create a schema. Everything very similar to the demos that I already presented with different sources. Okay, but next, now I have tons of data. You already, congratulations, have half a tera or maybe even 10 teras of information. And the next thing that you would like to do is to query that. So let's start with a couple of query demos. I see that we have, okay, I have a couple of minutes. I still have a couple of minutes. Let's continue. Custa logs. This is the actual logs. This is those are the actual logs of the service. Okay. Running in real time, working right now on the in production service of the entire Azure Data Explorer service worldwide. All the logs of the service for self-maintenance and self-control is running into one very, very safe table. No specific customer data, but all the logs are here, and let's try to understand how many records we have here. So it's million, billion, trillions, 36 trillions of records in one table. Let's see how much data we have in this one table. So we have 6.4 petabytes of information in our hot data, and in total of 18.7 petabytes of original data. At this point, you could see, this is very nice numbers of information. And if I will present the logs in the last hours, in the last hour, we can see that we have almost 15 millions of records an hour. No, per second, sorry. My confusion. 14 millions of records a second. So if your service required high performance, I think that this proves that the service can support it. All this, of course, and just one last thing that I would like also to share is the distribution of the errors of the logs in a minute, and you can see that we have a nice distribution of the errors in our logs. One important thing that is also that I want to present here is the performance. You can see that I just query a table with 16 trillions of records, if I remember correctly. I run a query, I just build a graph over this information, and the performance was less than a second of execution runtime. Those are the performance that you can get from ADX. Again, by the service without the requirements to manage it. Couple of additional nice stuff to share. Okay. So one of my favorite demos is from Power BI. Since we came and have started from Power BI, it's always nice to see that our history is a part of our creation. So here we took a sample of the Power BI logs, and we have built a cluster with 6 instances that supports (32 terabytes of data. Andrea, is it big enough? Do I need to increase the font?
I think right now it's readable.
Okay. If you need something, tell me. Okay, so we have a 32 terabytes of original data, but this number is more important, which is the 3 terabytes of the compressed data, because the cluster definition will be defined per data size and not the original. So think about the cost efficiency and the performance efficiency with this compressed mechanism. Till now, I presented KQL, but I guess that some of you ask about, what about SQL? I'm coming from SQL. SQL is more natural to me. I will answer with two different answers. First of all, start with SQL. You can see here that the service can support SQL. Second, we have explained operator that you can put your SQL statement and it will translate it into KQL statement. And third, you'll see in the second that we have wonderful courses, free of course, online courses, that in a couple of hours effort, 2 or 3, you can start and write your own KQL statement without additional thought. Worth it. Okay, so at this table we have 40.9 billions of records. It's relatively small to the other ones that we saw. The data includes different data structure. Most of it is structured data, but we also have free text of the entire logs for future needs, for future use. Here you can see everything in structure, but here we have the event text, which is the actual, log statement, different from one record to another. And you can see that I'm running this demo in real time. Nothing is cached, nothing is stored. It's actual now. We divide 1 day of data into the different error levels, and we get about 800 million of records in the different levels. Let's see the error distribution among the day. The data is distributed nicely, but here we have some hiccups of increased numbers. Let's see who are the customers that frustrated the most from those errors. In the following query, I have created a temporary table with the let statement of all the events from today, 800 millions. Then I look for all the users' IDs inside this table. How do I do that? I'm creating a new column, which includes the user ID, and I am extracted from the free text, from the event text that I presented earlier. So now I have a temporary table, temporary view with all the user IDs. And then I look at the table, the daily events table, and I look for all the users that exist in this table. I count how many errors each user has, and I sort it, and I take the most frustrated user, the user that has the highest number of errors, and I retrieve it. I just want you to think, I'm going to run these two temporary tables, searching for a specific text in a free text structure, something that is unpredictable at all. I'm also creating a sorting between all those 800 millions of records and retrieve only the top 10. Imagine how much time it's required in any other service to run this type of query. Now let's see how long it takes in Cousteau. Okay. And I got it back. And the most important part is the statistics. Even though that I'm running this query while I'm over my Wi-Fi, it took me 0.7 seconds to execute the query and to retrieve it to the service. Why? Because the service ran the query in the most optimized way to optimize the performance and the resources on the entire cluster capabilities. We divide it into the different nodes, retrieve the results from each node, and calculate the maximum. This is a very optimized algorithm to give you the best customer experience. Okay, I think that we are run out of time, so I will stop. I will stop now my demo, and I will get back to one very important slide. And then, Andrea, the stage will be back to you. So you saw a new service, a new experience, something that looks interesting, understand more, to learn more. So the very basic question is, okay, how should I start? How can I learn? KQL looks nice, but it's a new language for me. How should I start with the new experience? So we try to help you. First of all, there is a new MS Learn model on Introduction to Azure Data Explorer. There are 3 free online courses, KQL from scratch, ADX end-to-end, how to start with Azure Data Explorer, and also the advanced experience of KQL. This is for more advanced customers. We have a tech community that answers all your questions and also share all the updates of new feature, new capabilities, events, of course, Twitter, and we have our community. One very first blog post to start with is something that collapses everything into one page and present. I didn't open it in advance, sorry. Okay. All the content, all the links, all the places in one place, just a checklist to our journey with Azure Data Explorer. Okay. Q&A. Andrea, Mini, you are more than welcome to join. Andrea, take the stage, please. Thank you, everyone.
Yes, it's, yeah, if you can go on mute, we'll avoid some echo, I guess. Thank you, and we can alternate each other. So, first of all, thank you for driving us through. It was amazing to see the level of performance that the service, which is again fully managed and purpose-built, as you were saying at the beginning. It's amazing to see the level of performance that it can achieve on such a large volume of data. There were while you were talking, there were a few questions in the live chat, some related to particular features like materialized views and how do they work, which I think we have clarified well in the live Q&A panel. There is one question on which we would like you to elaborate a little bit further, which is your views and recommendations on how Azure Data Explorer sits within the wider ecosystem of services for analytics. So when we, in particular, I think we are referring at Synapse and Azure Databricks. So services, again, that helps addressing the analytics needs of the organization. What's your views on the decision tree, basically, or when you would, in what use cases and scenario you would adopt Azure Data Explorer, complementing the rest of the services for analytics on Azure? You're on mute.
Yeah, sorry, I put my, okay. It's an excellent question because, you know, it's a basic understanding, because there are so many options, and how should I decide where to use what?